Hello and welcome to another LeetCode video. Today we're going to be doing the next JavaScript problem, and it's going to be Throttle. And it's a pretty common JavaScript function, so definitely if you're learning JavaScript, it's a good one to learn. And so in this, you're given a function fn and a time in milliseconds. Return a throttled version of that function. A throttled function is first called without delay, and then for a time interval of t milliseconds can't be executed, but should store the latest function arguments provided to call fn with them at the end of the delay. For instance, if t equals 50 ms and the function was called at 30, 40, 60 ms, the first function would block calling functions for the following t milliseconds, the second function would save arguments, and the third call arguments should override currently stored arguments from the second call because the second and third call are called before 80 ms. Once the delay is passed, the throttle function should be called with the latest arguments provided the delay period. Then it should also create another delay period of 80 ms plus t. So let's actually go through these examples and let's draw a number line and understand what they're talking about here. Okay, so for the first argument, there's a delay of 100 and it's called at 20 ms. So let's just say here it is 20. And there is nothing throttling it, so the first time the function is called, it's going to be called without delay. So here it will just be called with, inputs 1. Let's just say a function will be called on 1, and then it will execute, and there's nothing else to do. Let's actually go to the second example to make it more interesting here. Okay, so in the second example, we have, let's draw another number line from 50, 100, 150, 200. And now let's take a look. Okay, so the first function is called at 50 with inputs 1. Okay, so let's actually draw that like this. So it's called here. So what we're going to do is we're going to actually execute fn on inputs 1, but now we need to throttle it for 50 seconds. So if something else gets called within this time interval, it should not be executed. And so the second function is called at 75 ms. So it's going to be called here, but it can't execute because there's a throttle here already. So this is blocked. So maybe we can draw it like green as this time interval is blocked. Okay. And it's called at 75 ms. So let's draw that, and then it should execute at 125. Actually, no, it should execute right when the first one unblocks it. So it's going to execute right here. And it has inputs of 2. So it's going to have, so it should call fn on 2, so it's going to have inputs of 2. And it will call inputs fn on 2 right here. And then let's see if there's anything else. So let's see here. 50, 75. Yeah, okay, so there is no other function that's called. So what's going to happen is this first one is going to execute, then the second one will be blocked, and then when it's unblocked, there's nothing else that's called afterwards, and then we're going to execute fn here on 2 at 100 seconds, and then we're going to create another block, but there's nothing else to execute. So we are going to create another 50-second block here, but there's nothing else after that, so that's what's going to happen. So the first function is going to execute at 50, and then the second one is going to execute at 100. Okay, let's go to the third example. I think that one's going to be the most challenging one. And so let's try to draw a number line from around 50 to 400 or so. Let's have some more space here. Okay. Yeah, because the first one is called at 50. Okay, so we're going to have 50, 100, 50, 200, 250, 300, 350, and 400. Okay, so now let's take a look what the flow of the information is going to be. So the first function is called at 50, and now the waiting period is 70 seconds. So it's going to be called at 50 here, and the waiting period is until 120. So now this section is going to be blocked, so anything called here won't be executed. It will have to wait. So here we are going to call fn on 50. Actually, we're going to call fn on inputs 1, so we're going to call fn on 1. Now the second function is called at 75, but it can't actually execute till here. So we're just going to say it has to wait till at least this point, and its input is 2. Okay, now the third function is called at 90, which is up here, but the second function hasn't executed yet. So the third function is going to be called at 90. It still has to wait till this point. So it still has to wait at this point. But because this hasn't executed and another function was called, we actually need to delete this waited function. We actually need to say if something was waiting in the queue, we actually need to throw that away, and let's give more arguments. And so here we have inputs 8. Okay, so fn is going to be called at 120 still with inputs 8, provided nothing else has been called. So now what's going to happen is this function is going to be called at 120 because the next function is at 140. So this one will have enough time to go. So if it's called at 120, there is a 70-second block, meaning that it'll have to wait till 190. So it'll make a block till 190 here. So it will be called at 120, but then the throttle will make sure nothing else is called till 190, right? Okay, so let's go to the next one. Then the next one is at 140. And so the one called at 140 won't be able to execute right away because there's a block here. And so it will have to wait until 190 to execute. And what are the parameters for that one? So the parameters for that one are, let's take a look here, 5 and 7. So this will take these parameters and then it will execute it once it's unblocked, essentially. Okay. Yeah. And then the next one, and then so it will execute because the one after it is at 300. It will execute at 190, and then it will create another 70-second block. So if it's at 190, it'll make a block till 260. So everything will be blocked until 260. And finally, the last function is called at 300 with arguments 9 and 4, which will be fine to execute. And then it will also create a 70-second block. So nothing will be able to call until 370, but there's nothing afterwards. And so you can see, so let's go through what happens here. So function 1 does get called. Then, well, like the first call does get called. So it says like, yeah, the first one's called. The second one tries to be called, but the third one will override the second one. So we're not actually gonna call the second function. We're just gonna call the third function. So you can see the outputs here. The second one gets overridden. Yeah, the second one gets overridden, and then the third one gets called at 120. Like I said, right? It gets called here at 120. It has to wait, so it gets called at 120. And then the fourth one has to wait until 190, so it gets called at 190. And then the last one finally gets called at 300 seconds. So we have to do a couple things here, and I can probably write what those things would be, right? So let's just write some stuff. Let's make it a little bigger. So first of all, we have to say if a function can be called, it will be called, right? So if a function can be called because there is no wait time, let's call it and set a wait time. Right, so that's one of our rules, is if a function can be called because there is no wait time, let's just call it and set a wait time like this first function. That's fine. Otherwise, what's going to be our other thing? So let's just make it in this color. Otherwise, we have to clear interval and make a setTimeout to wait until the wait time expires. Right, so essentially, if we can call, let's call right away and let's set a wait time. Otherwise, we can't actually execute our function right away. So we have to do clear interval because, or sorry, it's actually going to be it's not going to be a clear interval. It's actually going to be a clear timeout here. Oh, yeah, so this is actually going to be a clear timeout. So I wrote clear interval, but it's going to be a clear timeout because essentially, like for this function here, we're gonna set timeout here, but then when we call this function, we need to override its arguments. So if there's something waiting in the queue, then we're just gonna delete it. So we're gonna do a clear timeout, and then we're gonna do a set timeout to wait until the wait time expires, essentially, right? And so, and also, yeah, so that's actually it. So these are the only two cases. If a function can be called, let's call right away, and let's set this like wait time where nothing else can actually be called, but things can be called with setTimeout, right? And then I'll show you like how to do that and like what useful functions we're gonna have. But essentially, it's these two cases. either call it right away and let's set a wait time while nothing can get called, or let's clear the other parameters that are in waiting, if there are any other parameters in waiting, and let's make a set timeout to wait until the wait time expires to call this current function. And then if there's something else that overrides that, we'll keep doing that and so on. Okay, so let's actually try to code this up. So what we need to do here is we need to do a couple things. So first of all, we're going to have some variables in this throttle function. And so a really nice method you can use in JavaScript to check, like for your delays, is called Date.now. And essentially what Date.now does is it gives you the number of milliseconds. I don't remember the exact implementation, but it's something like the exact milliseconds that went from like 1970 or 1700 or sometime a long time in the past. So you can use Date.now to get that time, and then if you just do a subtraction, right? So if you just say like, okay, let's get a Date.now, and it'll give me some number of milliseconds that, you know, the number of time that passed since the last 300 years or whatever, and let's do a later Date.now, we can simply subtract this newer one and this other one to get the difference. And so really the power of Date.now is subtracting them, not actually getting the exact time, because like I said, the exact time is kind of useless because it's just like a big number. Okay, so what we're going to do here is we're actually going to set our time to 0 because in the beginning, nothing has been called. And so then when we call Date.now and we subtract it from time, Date.now is going to be a huge number, and so our first function is going to be able to run. So we're going to set our time to 0, and we need one more thing. So we need the timeout that we're going to be clearing. We can set that to null. So the nice thing about clearing timeouts that aren't actually existent is it's not going to do anything, which is totally fine. And also it's totally fine to clear a timeout that actually passed already. So if you call setTimeout and then it already executed and it's already done and you do clearTimeout on it, nothing's going to happen, right? Because it's already done. But if it hasn't executed yet, then it will clear it. Okay. So now what we actually need is we need to calculate the delay that we have from the last time the function was called. So we are going to make this 0 initially. So if you do something like this, const delay equals Date.now minus time. This Date.now will be a really big number at first, minus time. So this will clearly be bigger than our waiting time, right? But we have to check if it is in the future. So the first time it will obviously be called, but in the future it might not be, right? So if delay is greater than or equal to time, meaning we've waited enough time, we can call the next function, then let's just call that function. And then also what we need to do is we actually need to set a new delay time, right? And so the way to set a new delay time is let's just say time is Date.now, and then we can get a new Date.now in the future, and we can subtract it from this. We can do Date.now in the future minus time in the future, right? So once we call this again, we're going to just do Date.now minus time, and then we can check this, is that greater than or equal to delay in the future, right? And so if it isn't, that means we have to keep waiting. Okay. So we're going to get the new delay time. And that's pretty much all we have to do for this case, right? So this is the case where if we can run the function right away. Okay, now we have the else case where we can't run the function right away. And so if we can't run the function right away, remember, we have to clear the timeout of something else that might be pending to run. We have to clear that because we're given new parameters. So we're going to clear timeout. And we have to, this is why we have this timeout function, or this timeout variable, because we need access to it. That's pretty straightforward. Now we're going to set a new timeout. And so I think I talked about this, but the way setTimeout works is it returns a variable that you need to use to do clearTimeout on it. So we're going to do setTimeout here. And setTimeout takes a function. So we're going to make a function. And what do we need to do in that function? So what we need to do in that function is we need to actually get the time again, right? And so we need to do that. But what we also need to do is we need to make sure, we need to know like how long are we actually waiting, essentially, right? And so what we actually need to do is we need to figure out like how long do we have to wait to actually execute this function, essentially. So what we need to do is we need to actually call the function. We are gonna do a setTimeout, so this will wait, but we have to figure out like how long are we actually waiting at this point, and that's going to be our concern here, right? But also keep in mind we have to do one more thing. So when this function is called, when this function is actually called with setTimeout, we have to actually set a new delay. And so because we have to set another delay, we're going to do time equals date.now again, because we're saying, okay, let's do a set timeout on this function. Let's wait some time to call it. But once it's actually called, we have to do this function on the arguments, and then we have to get a new delay. And so we need this time date.now to make sure to use our new delay. And then how long do we have to wait to call this function? Well, that's pretty straightforward, right? So if t is our total time we have to wait, and delay is how long we've actually waited, so we have to do this, right? This is how much more we have to wait. So delay is less than t. These are probably not the best variable names, but essentially t is the actual time we have to wait, and delay is how much we've waited so far. And so how much more we have to wait is t minus delay. Okay. And yeah, so that's actually going to be it. So let's go over it one more time. I think it says we're not using this clear timeout, which is definitely interesting. Let's see here, because we definitely should be. And why are we not? Let's take a look. So we can actually put it here. Oh, no. It's fine here. It's just because yeah, misspelling. Okay, now there we go. So we don't actually need it up here. Yeah, we can put it here to be safe, but in reality, if you think about it, if this is the case, then there can't be anything there can't be a set timeout. So we actually only need it down here. Okay, so hopefully I didn't misspell anything, and it looks like I did again. Okay, now I think we should be good. So let's go over this one more time. So the time is actually what we're going to be using to check if we waited enough. And then the timeout is what we're going to be using to clear something that might be running, something that might be pending to run. And so I'll talk about this date.now one more time, last time. So date.now is going to give you the number of milliseconds that passed till 1970 or 1700, whatever, some number, some really big number. And in the beginning, time is actually 0, so this will just give you a huge number, so this will obviously be true. And if that is true, we're just going to let the function run, and we're going to set a new time to date.now, because we can subtract times to make sure that our new time minus our old time is greater than delay, which means we've waited long enough. And so in the else case, we're going to clear timeout if there is something running, and if this is null, it's totally fine, it'll still work. And then we're going to get a new timeout variable so we can clear this timeout if we need to in the future. And then once we've waited long enough in our set timeout, what do we need to do? Well, it's pretty much the same thing. So we need to call function on the arguments, and then we need to get the time. We need to set the new time, and how long do we have to wait? Well, it's actually, t is the total wait time, and then delay is how long we've waited already. So how long we have more to wait is the total wait time minus how long we've waited already. Okay, so let's try that out. All right. And let's take a look. Okay, so that actually does run. I do think it's not a super difficult function once you kind of get the idea of what's going on. And honestly, the key to solving this problem is know where you have to update your times and know where you have to clear your timeouts. Like I said, you can technically put it up here. It'll still work. But you do have to realize that once you actually do call this set timeout, you have to update your time again. And then, so yeah, so this date.now is super useful for clearing timeouts, for comparing like how long things have been running. You can also do things like, if you want to test how long a function has been going, you can say like, all right, let's get the time, let's run the function, let's get the time again, and let's do a subtraction there to see like how long a function has been going in milliseconds. So that could test your efficiency of functions. I did that before, where you have like an O of n function, O of n squared function. You can actually check like, oh yeah, this actually does take a lot longer. Okay, but that's going to be it for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.